Hello everyone. In today's lecture, I will be discussing another method of solving linear programming problem, that is simplex method. In previous video lecture, I discussed about graphical method. In this video lecture, I will be discussing about simplex method. So before proceeding further, let me remind you about the modifications that we used to do to convert any linear programming problem into standard form. So I told you that there are three modifications that we do to convert any LPP into standard form. So among those 3 points, I will be repeating one point here because it will be needed in this simplex method. So that point is, as I've already told you, that if the inequality constraints are there, that is, if a constraint appears in the form of less than or equal to sign in the linear programming problem, then to convert that inequality constraint into the equation form, what we do, we add a non-negative slack variable to convert it into the equation form. Similarly, if the inequality constraint is of greater than or equal to sign, so to convert that inequality constraint into the equation form, what we do is that we subtract a surplus variable. So this point is needed in this simplex method. So let's start solving the question. So this is a linear programming problem. We will be solving this linear programming problem using simplex method. Here the question is maximization of objective function, and the objective function is z is equal to 12x1 plus 16x2, which is subjected to two constraint equations, 10x1 plus 20x2 less than or equal to 120 and 8x1 plus 8x2 less than or equal to 80. So using simplex method, how we going to solve this problem? To start with, as I've already told you, the objective function given in the question is 12x1, z is equal to 12x1 plus 16x2. So I have written this thing here, that is the objective function is maximization of objective function is equal to 12x1 plus 16x2. Next step, what we do is the inequality constraints that are given in the question, I will be converting those inequality constraints into the equation form using that modification point that I have already discussed now. So how I will be doing, as I've already told you, if the inequality constant is less than or equal to sign, to convert it into equation form, I will be adding a slack variable, non-negative slack variable to that equation. So 10x1 plus 20x2 less than or equal to 120. So to convert this inequality constant into equation, I will be adding a non-negative slack variable s1. So it will get converted into the equation as 10x1 plus 20x2 plus s1 is equal to 120. Similarly, the second inequality constraint equation, that is 8x1 plus 8x2 less than or equal to 80, can be converted into the equation form by adding another slack variable as shown here, that is 8x1 plus 8x2 plus s2 is equal to 80. Now, therefore, I have added two slack variables here to convert the two inequality constraint into the equation form. Now I will be introducing these slack variables s1 and s2 into the objective function. So as you can see in this slide, I have introduced the slack variables s1 and s2 into the objective function. Now my objective function has become z is equal to 12x1 plus 16x2 plus 0s1 plus 0s2. And these were below. I have written the two equations that I've told you how to do it. So next step, here as you can see, initially there were only two basic variables in the question, x1 and x2. Now because I have introduced two slack variables, so now there are four basic variables, x1, x2, s1 and s2, and they all are greater than and equal to 0, greater than or equal to 0. Next step is I will be framing a initial simplex table. So this is the initial simplex table where Cj, C subscript j, represents the coefficient of objective function. Then there is basic variable, then solution ratio, and then CBI. So I will be telling you step wise what are they and how to fill these rows and columns. Starting with Cj, as I've told you, Cj represents the coefficients of the objective function. So as you can see, my objective function here is z is equal to 12x1 plus 16x2 plus 0s1 plus 0s2. So the basic variables are x1, x2, s1, s2. Again I am repeating, from this you can deduce the basic variables as x1, x2, s1 and s2, and from this equation, from this objective function equation only, you will get to know the coefficients of the objective function. So what are the coefficients? They are 12, 16, 0, 0. So what are the coefficients? They are 12, 16, 0, 0. So I will be writing these coefficients in the Cj row. So I have written it here in the Cj row. I have written 12, 16, 0, 0. So these are the coefficients of the objective function. Now in the basic variable row, I told you that there are four basic variables now in this question, and they are x1, x2, s1 and s2. So I have written these basic variables accordingly. Now below the basic variable column, I will be writing the newly introduced basic variables, that is slack variables, that is s1 and s2. So below the basic variable column, I have written s1 and s2, that is the newly introduced basic variables. Now in the CBI, that is CBI representing the cost of the basic variables. So since s1 and s2 slack variables are having zero coefficient in the objective function, so their coefficients I have written in the CBI column. Again I am repeating, as you can see from the objective function, s1 and s2 are having zero coefficients. So I have written those zero coefficients in the CBI column, that is cost of basic variable. Now next step, what I will be doing is I need to find this slack variable s1 is present in which equation. As we can see here, the slack variable s1 is present in the equation number 1, that is 10x1 plus 20x2 plus s1 is equal to 120. So I will be writing the coefficients of this equation number 1 in the next step, that is in the row of s1. So in the row of s1, I will be writing the coefficients of the first constant equation, as I've written it here, 10, 20, 1, 0. Again I am showing you the first equation was having coefficients 10, x1, 20, x2 plus 1, that is coefficient of s1 here is 1, plus coefficient of s2, since there is no s2 term here, so the coefficient of s2 term is 0. So what are the coefficients? They are 10, 20, 1, 0, and I will be writing the coefficients in their respective place. That is, with x1 I will be writing 10 only, with x2 I will be writing 20 only, with s1 I will be writing 1, and with s2 I will be writing 0. So as I've already done it here, like 10, 20, 1, 0, with x1 I have written 10, with x2 I have written 20, with s1 I have written 1, and with s2 I have written 0, and in the solution I have written 120. That is, as you can see, the equation is equal to 120. So 120 is the solution. Again, I am repeating the next step. What are the steps that I have done in the simplex method? First step that I did is I converted the inequality constant equation into the equation form by adding slack variables. The next step that I did was introduce those slack variables in the objective function. Then the next step was I framed this initial simplex table. Next step was I filled the coefficient of objective function in the Cj row. These were the coefficients of objective function. Next step was I wrote all the basic variables in this question. The basic variables were x1, x2, s1 and s2. I wrote all the basic variables. Then I wrote the newly introduced basic variables, that is slack variables, below the basic variable column. So I have written s1 and s2 and the coefficients of these slack variables in the objective function. I have written those coefficients in the CBI column. Next, what I did, I found s1 is present in which equation. It is present in the equation number 1. I wrote all the coefficients of that equation number 1 along with the solution. So again, I am repeating here. The coefficients of the equation number 1 are 10, 20, 1, 0 with solution 120, and I have written all those coefficients in their respective place. That is, with x1 10, with x2 20, with s1 1 and with s2 0, and the solution is 120. The next step, I will be repeating the same thing only. I will be finding my s2, that is s2 slack variable is present in which equation. As I can see, the s2 slack variable is present in the equation number 2. Therefore, I will be writing all the coefficients of the equation number 2 in the row where the s2 is written. So what are the coefficients? The coefficients, as you can see, x1 is having the coefficient 8, x2 is having the coefficient 8, s1 is having, since there is no s1 term, so s1 is having the coefficient 0 and s2 is having the coefficient 1 with solution 80. So what are the coefficients? They are 8, 8, 0, 1 with solution 80. So I will be writing those coefficients here, 8, 8, 0, 1 with solution 80, and I have written accordingly in their respective place. That is, with x1 in the second equation, with x1 the coefficient 8 was written, so in the column of x1 only I have written 8. Again, in the with x2 the coefficient was 8 in the second equation, so in the x2 column only I have written 8. Similarly with s1 and s2. Now next step is I need to find Zj. So how will I be finding Zj? Zj can be found from the formula. Zj is equal to summation of I is equal to 1 up to 2. Here I have written 2 because there are 2 variables only. Multiplication of CBI into Aij. So let me explain this formula. First of all, I need to write the first element of Zj, or you can say first column of Zj. So in the row of Zj, I need to write the first element. So what will be the first element? As per the formula, I have used the orange lines to make it more clear. For the first element of Zj row, that 0 into 10 plus 0 into 8 will give you the first element of the Zj row. So 0 into 10 plus 0 into 8 is 0. So I have written the first element of Zj row to be 0. Again, the second element of Zj row can be written in the same way, that is Cbi into Aij. Cbi column into Aij. Aij is representing the elements of the matrix, that is 10, 20, 1, 0, 8, 8, 0, 1. So for finding the second element of the Zj row, it can be found. I've represented it using the green lines. You can see it can be found from 0 into 20 plus 0 into 8. Similarly, for which will give you 0. So here again I have written 0 in the second element of the Zj row. Again, for finding the third element of the Zj row, I have drawn it with the blue line, that it can be found from 0 into 1 plus 0 into 0, which will give 0 only. Again, I have written 0 in the third element of the Zj row. Similarly, all other elements can be found in accordingly. So what here I am doing, I am multiplying summation of what is the formula? It is for finding the Zj row. The formula is summation of multiplication of Cbi element with that of the corresponding column for which I will be finding the element of Zj row. So in this way I found the Zj row. Now the next step is I need to find Cj minus Zj. So Cj is, I've told you, it is the first row, that is objective function coefficient, and Zj we have already found what is Zj. So the next step is to find Cj minus Zj. So the first element is 12. How it came? Cj is 12 and the corresponding element for Zj is 0. So 12 minus 0 is 12. For the second element of Cj minus Zj row, it can be found because the second element of Cj is 16 and the second element of Zj row is 0. So 16 minus 0 is 16. In the similar way, all other elements can be found. So the third element is 0 minus 0, that will be equal to 0, and the fourth element is Cj minus Zj. 0 minus 0 is 0. So in this step we have found Cj minus Zj. Next step, I need to find whether the solution has reached the optimum value or not. So for optimality condition, if the question is of maximization type, means maximize the objective function, then I need to verify all the elements of Cj minus Zj are less than or equal to 0 or not. If they are less than or equal to 0, means if they are equal to 0 and or negative value, then we have reached the optimality condition. Otherwise, we have to proceed further. And for minimization type, minimization type of question, that is minimization of objective function, if it is given in the question, then what I need to do is I need to verify the elements of Cj minus Zj row, whether they are greater than or equal to 0 or not. If they are greater than or equal to 0, then we have reached the optimality condition. Otherwise, if it is not greater than or equal to 0, then we need to proceed further. So since this question, the question that I am discussing here, is of maximization type, as I've told you, the question is maximization of objective function. So what is the optimality condition here? The optimality condition here is Cj minus Zj should be either 0 or negative value for the optimality condition. So as I can see, the Cj minus Zj that I have obtained here, they are not negative value, they are either positive or 0 value, which means I have not reached the optimality condition, so I need to proceed further. So the next step is in the Cj minus Zj row, I need to see which is the largest number, which is the maximum positive value. So as you can see, the elements are 12, 16, 0, 0. Among these four elements, 16 is the largest positive number. So I will be marking the column corresponding to 16. I have encircled that column here in this slide. So the column is 28. What I have done, again I am repeating, I will be verifying in the Cj minus Zj row which element is the maximum. So here 16 is the maximum. So I have encircled the column corresponding to 16. That is 20 and 8. The next step is what I will be doing. I need to find the ratio. Initially the ratio wasn't there. Now I need to find the ratio. So how I can find the ratio? Ratio is solution divided by the encircled column, or I can say the encircled column is the key column. It is the key column. So solution divided by the key column. So ratio for the first element of ratio column, it is equal to 120. Solution is 120 divided by what is the corresponding element of key column? It is 20. So it is 120 divided by 20 and it is equal to 6. Similarly, for second element of ratio column, what I will be doing, I need to find what is the solution. The solution is 80 and the corresponding element of the key column is 8. So 80 divided by 8 is 10. So the ratio that I have obtained is 6 and 10. The next step is I need to find which is the minimum value among the values that I have obtained in the ratio column. So in the ratio column among 6 and 10, it is obvious that 6 is the minimum value. So I will be encircling the row corresponding to 6 in the ratio column. So here I have encircled the row corresponding to 6. So the row is 10, 20, 1, 0, 120. So again I am repeating, the column that I have encircled is key column and the row that I have encircled is key row, and the intersection of key row and key column is occurring at an element 20. 20 is the overlapping or the intersection element. So 20 is the key element, is called the key element here. So again, one more thing I want to say is that as we can see, the key column that is 28, key column is written below the x2 variable. So whichever is the key column, in many questions you will be finding the key columns. So whichever is the key column, that corresponding variable is called the entering variable, and whichever is the key row, the corresponding variable will be called the leaving variable. So here the entering variable, that is variable corresponding to key column, is x2. So x2 is called the entering variable, and the variable corresponding to key row, the variable corresponding to key row is called the leaving variable, and here it is s1. Now next step is I need to frame another table that is called iteration 1. So in iteration 1, the same thing I will be writing, that is CBI, CJ, BV, that is basic variables, solution. So again here in this iteration 1 table, CJ, that is coefficient of objective function, and the basic variables row, these two rows will remain same as we did in the initial simplex table. So what were the elements? The same elements that we have written in the initial simplex table, that is 12, 16, 0, 0 in the coefficient of objective function. The same coefficients we have written here. Basic variables are x1, x2, s1, s2, the same thing that we wrote in the initial simplex table. Now, next step is I need to write below the basic variables. So initially in the initial simplex table that I made, the basic variables, below the basic variables I wrote s1 and s2. But in the iteration 1 table, what will be the elements that I will be writing below the basic variable? First one is the entering variable. As I told you from the initial simplex table that x2 is the entering variable and s1 is the leaving variable. So in place of s1, this time I will be writing x2. So in the iteration 1 table, I have written below the basic variable x2, as I have told you that x2 is the entering variable. Now what is the coefficient, that is CBI, below the CBI in this column? What will be the value of x2, corresponding value? It is the coefficient of objective function. As you can see that from the question only, you can find that the coefficient of objective function, coefficient of x2 in the objective function is 16. So I have written the same thing below CBI. Now the next step is I need to fill the elements in the x2 corresponding to the x2 row. So how will I be filling the elements? Let me again go back to the initial simplex table. In the initial simplex table, the first row elements were 10, 20, 1, 0, 120. And the key element that I found from the initial simplex table, from the initial simplex table was 20, that I have already discussed, 20. So what I will be doing is I will be dividing the elements of this row, that is corresponding to S1 with the key element to get the first row, to get the row for the iteration 1 table. Again, I am repeating what I am doing here from the initial simplex table as it is shown in this slide. From the initial simplex table, the elements, the old elements, I will be dividing the old elements by the key element to get the elements for the iteration table 1. So here the key element is 20 and the row and the elements of the row corresponding to S1 is 10, 20, 1, 0. So I will be dividing by 20. So 10 divided by 20 is 1 by 2. 20 divided by 20 is 1. 1 divided by 20 is 1 by 20. 0 divided by 20 is 0. And 120 divided by 20 is 6. So what are the elements that I have got after dividing by 20? They are 1 by 2, 1, 1 by 2, 1, then 1 by 20, 0 and 6. So same elements, these elements only I have written in the iteration table 1 corresponding to x2 row. 1 by 2, 1, 1 by 20, 0 and 6. Now I need to further fill the table. So below the first basic variable that I got in the iteration table 1 is x2, as it was the entering variable I told you in the initial simplex table only, and it is written in place of s1 slack variable. Now the second row will remain same, that is second row will be the s2 slack variable only, and it is and its value corresponding to CBI column is 0 only, because this CBI column is representing the coefficient of basic variable in the objective function. So in the objective function, the coefficient of basic variable S2 here is 0 only. So I have written it 0. Now, next step is I need to fill the row for S2. So there is a formula for filling the row of S2, and what is the formula? It is equal to old value minus corresponding key column value into corresponding key row value divided by key element. So class, let me end this video lecture here. In the next video lecture, I will be telling you the further steps of this simplex method.